welcome back to a new recording. In this recording, I'll be talking about the buffer solution, the types of buffer solution, and then we will be solving questions in order to practice how to be prepared for the buffer solution. Guys, the buffer solution, simply in a short sentence, we can say that is a solution that can resist change in pH. Therefore, any solution has a tendency to resist change in pH. While we add an amount of acid or base to the solution, it resists change in pH. We classify the solution as a buffered solution. From the figure 8, it's appear that the differences between buffered and unbuffered solution can be observed. What are the differences? Guys, uh, in part A, here we have got two solutions. The first one to the left is buffered solution, and then the other to the right it's a unbuffered solution. Both solutions they have a pH value of 5 as it's written here. The pH of both solutions are 5. Then we have another case which B, part B in the figure 8, we add an amount of acid or can be base as well, a 5 milliliter of 0.10 molarity of HCl added to both solution equally. As you can notice that the buffered solution its color unchanged uh, due to of its resistance in changing pH. The pH stay almost as 5 while we add an amount of acid into it. But the one to the right, the color of the solution changes and the pH dramatically reduced to 2.17. This is the effect of the buffered solution or the difference between buffered and unbuffered solution. What are the types of the buffer solution? We have got two types of buffer solution in our curriculum. The buffer solution which uh, it can be formed between the weak acid and a weak base with the salt. This is the first type. For weak acid or weak base with its common ion from the salt, that means a weak acid with its salt, a weak base with its salt, and then the next one when a strong acid base reacted with the weak acid base, the amount of the weak must be higher than the strong. The second type of buffer is in between the acid and the bases, but one of the acid and the base should be weak, the other strong, and there should be the condition that the amount of this weak, the concentration of the weak should be higher than the uh, strong in order to form a buffer solution and let the buffer solution to be formed in between them. We have got two types of buffer in terms of acidic and basic. The acidic buffer and the basic buffer. The acidic buffer and the basic buffer it refers to the uh, whether the weak acid use it or a weak base. If the weak acid use it with its common ion or the its salt, we call as the acidic buffer. If the weak base with its salt is used, we call the type of the buffer as the basic buffer. Let us talk about the first type, which is acidic buffer. And then, guys, for each of these types, we have got two conditions, or we can say that we have got two possibilities when we add a small amount of acid into it or a small amount of the base into it. By the way, why we add a small amount of acid or base? Because If we add a high amount of the strong acid and strong bases to the buffer solution, the solution's tendency will not be able to resist change in pH due to of producing a high amount of hydronium and hydroxide by the strong acid and the strong bases. That's why this is the condition: a small amount uh, of the strong acid and a strong base should be added in order to let the buffer solution to resist change in pH. Otherwise, the pH, the solution will no longer will be buffer solution. Its pH dramatically change. Why we use the strong acid and the strong base? Why not weak acid and weak base? Because the strong acid and the strong bases, they produce hydronium and hydroxide more than the weak acid and the weak bases, and then we observe the function of the buffer solution better when we use the strong acid and the strong base to resist change in pH. Let us talk about the first type, which is acidic buffer. As I told you, why we mention or we call this as acidic buffer, because it's weak acid. In part A, let us add an amount of acid into the acidic buffer. Guys, here we have got the representation. This part, we have got the buffer solution. This is the buffered solution. How do you know it's buffer solution? Because we have got a weak acid with it is salt. Probably, usually, the weak acid has a basic salt, and the weak base has a acidic salt, guys. The acid with its salt, they form buffer. In part A, and then part B. In part A, let us add an amount of the strong acid into acidic buffer. Strong acid, that means hydronium. Therefore, we add the hydronium concentration. According to Le Chatelier's principle, when we add hydronium, the amount of hydronium initially here elevates or increases. And based on Le Chatelier's principle, when we add a species or a substance in any side, it directs or shifts the reaction to the opposite side. In this case, the reaction shifts toward the reactant side. Shifts toward the reactant side. You may guess that the hydronium concentration increases due to of adding nitric acid, which is a strong acid, but that's not the case. Why? Because, guys, the hydronium added due to of nitric acid consumed by the shifting the hydronium to form HF and H2O, hydrofluoric acid and then water. In this case, the added amount of hydronium consumed simultaneously due to of the shifting of equilibrium based on Le Chatelier's principle. So, in this case, we can say that there is no change in concentration of hydronium, no change. On the concentration of hydroxide as well, pH, pOH, Ka, and Kb. The following values are unchanged, they stay constant. But what will happen to the other concentrations? Guys, when the reverse direction shifts the concentration of HF, which is the non-ionized weak acid, increase, the direction, the favorite direction is reverse favorite in this case. This is the second important point we have to mention. And then what happened to the ionization, guys? The HF ionize in the forward direction, but here the reverse direction favorite. Therefore, the ionization of the HF reduces, we can say the non-ionized HF molecule, which is the concentration of HF, increases. That's the effect is of adding an acid into a buffer solution. Let us add a base into the same solution. Let us add a base. A base, guys, we mean hydroxide. Whenever we add hydroxide to the same solution, the hydroxide has tendency to react with hydronium and form H2O. As you can see, this is the neutralization. Hydroxide has tendency to form to react with the hydronium to form H2O. Therefore, this is not the H2O in the reactant. It's not. It will take the hydronium and react to form H2O in a individual reaction. In this case, the hydronium concentration initially reduces. Therefore, in order to compensate the hydronium, the losage of hydronium, the reaction shifts toward the product, and then there will not be any change on the hydronium totally. Why? Because the amount of hydronium that reduces or consumed due to of the addition of the base compensated by the ionization of the weak acid. So we can say that there is no change on the concentration of the hydronium, hydroxide, pH, POH, Ka, and Kb. These values, they stay constant. But what will happen to the direction? Of course, the direction shifts to the forward, or we can say to the right side. Forward direction is favorite. And then what will happen to the concentration of HF, non-ionized HF, reduces because it's consumed to produce the hydronium or compensate the hydronium. And then what will happen to the ionization? In this case, the ionization of the weak acid increases because it ionizes in the forward direction. That's the effect of the addition of acid and base into acidic buffer in detail. Let us talk about the second type, or part B, when we have a basic buffer, which we mean the weakest base, and then add a hydronium acid or hydroxide base. What will happen to the uh, quantities of the hydronium, hydroxide, and the other quantities as well? Guys, in order to understand how it works, let us examine addition of hydronium here. Hydronium reacts with hydroxide to form H2O in a reaction, and then when the hydroxide initially reduces, the shifting goes toward the forward direction, and then what will happen to the hydronium and hydroxide? There will not be any change. Why? Because the hydroxide, which consumed due to of the addition of the hydronium, compensated by the ionization of ammonia based on the Le Chatelier's principle, shifts toward the product side. Therefore, there will not be any change on the pH, POH, hydronium, hydroxide, Ka, and Kb values. These values, they stay unchanged, constant. What will happen to the ionization of the ammonia? In this case, the ammonia ionizes more. Ionization increases. Why? Because the forward direction favor it, and then ammonia ionize in the forward direction. What will happen to the concentration of non-ionized ammonia? Reduces. It consumed to produce or compensate the hydroxide. And then we can say the forward direction in terms of direction favorite. Let us talk about when we add a base into the same solution, basic buffer. Guys, addition of the base, we mean hydroxide. And then when we add a hydroxide into the basic solution or basic buffer, the hydroxide initially increase and then shifts the reaction toward the reactant side. Therefore, what will happen to the direction, the reverse, or the reaction toward the direction toward the reactant side favor it, and then concentration of the ammonia increase because of the formation of more ammonia. And what will happen to the ionization of the ammonia reduces because it ionizes in the forward direction, but in this case, due to of the addition of the hydroxide, the shifting goes toward the reactant reverse direction favorite. And then what happens to the hydroxide hydronium? Guys, initially hydroxide increases, but due to of the shifting to the reactant side and in consumed, therefore the added amount of the hydroxide due to of the base consumed to form the ammonia and H2O in the reactant. There will not be any change on the hydroxide hydronium pH and pOH with Ka and Kb value, they stay constant. This value stay constant, guys. That's the effect of buffer. Therefore, whenever it talks about the buffer solution, you have to be careful about the pH, pOH, hydronium hydroxide, K, Kb values. They stay constant, but the only terms that can be used to change the direction, the concentration of the weak acid and the weak base, and then the ionization. Uh, what will happen to those? You have to know. Simply, guys, we can say that whenever the added quantity is the opposite to the quantity which formed the buffer, we mean the when the acid added to the basic buffer or base added to the acidic buffer, okay, guys, the shifting goes toward the forward always, acid into basic buffer or base into acidic buffer, and they are opposite to each other. The one that added is the opposite to the one that formed the buffer. In this case, is always the forward favorite, and then the ionization increase, and then the concentration of the weak acid and the weak base decrease. But if the added quantity is the opposite, is the same, sorry, is the same as the quantity, the species, the substance that formed the buffer, we mean the if the base added to the basic buffer or acid added to the acidic buffer, in this case, always the reverse favorite, and then ionization reduce, concentration of the weak acid and the weak base increase. Let us back to solve questions, practice a few questions, guys, here of the details about the acidic and basic buffer, which I have explained. When we add this question, how to recognize whether the question is common ion or a buffer solution, because the buffer solution formed between the weak acid and a weak base with their salt, and also this is a common ion, as you know that. Always, guys, there should be in buffer solutions three species. Have a look on this question. A base, the first species, added into weak acid with its salt. So here we have got three substances, three components. That's the sign to recognize the buffer solution, and the question asks for the buffer solution. When we add a base into weak acid, I told you whenever they are the opposite, that means the forward direction favorite. Weak acid molecules increase? No, because the weak acid molecule in the forward direction, its ionization increase and it consumes. Ionization of the weak acid molecule increase? Yes, that's correct. Precipitate forms? No, there is no precipitate hydronium increase. There will not be change on the hydronium, hydroxide, pH, and pOH of the solutions, guys. Let us solve questions, more questions, practicing more questions in order to know how to be prepared for the types of question. If NaOH is added to a solution of ammonia and NH4CO, this was the ministerial exam question. Guys, the how to know its buffer, because we have got three components: a base added to a basic buffer. Base added to a base, they are the same. That means the reverse direction favored on the weak base reaction. Therefore, whenever the reverse favorite, there will be reduction in ionization, but increasing the concentration of the weak base. Concentration of hydronium ion increase, no, there will not be any change on the concentration, because this is the buffer solution. A buffered solution, there will not be change on the hydronium, pH, pOH, and hydroxide. More of the weak acid ionizes, no, we do not have weak acid here in this reaction, guys. More hydroxide ions form, there will not be any change on the hydroxide, guys. More water and non-ionized base form, yes, that's right, correct, because as the reverse favorite, there will be formation of the H2O, and then ammonia concentration will increase. Which mixture of the following solution is buffered solution? Another type of question, resemble to the ministry exam questions. Guys, whenever asks for such questions, you have to choose the weak acid, weak base with the salt that they contains common ions of the weak acid and the weak base. NaCl and HCl, it's not, because it's strong acid with a neutral salt. HNO2, it's a weak acid. NaNO2, it's salt. Yes, B is correct. Why? Because HNO2 is weak acid, and NaNO2, it's the basic salt of that weak acid. It can form the buffer solution. NaCl and HNO2. HNO2 is weak acid, but NaCl is not the salt of HNO2. It does not contain the common ion of the HNO2, so it's not buffer solution. And then B is the correct answer, guys. Uh, there will be another type of question, the second type of buffer. Let us pass to the 51, page 51. There is a type of buffer solution, uh, which is between the weak acid, weak base, with the strong acid and the strong base, guys. There will be such questions like this. In this case, guys, when we have got the amount of the weak acid and the weak base, the condition for a buffer to be formed is that when we have an amount of the weak acid and a weak base with its salt remain in the solution. Have a look on this. Amount of the weak acid is higher than the strong base. This will form buffer, but how? Guys, when zero point 0.2 mole of HF reacts with zero point 0.1 mole of NaOH, they both, completely NaOH consumed, there will not be any remainder, but zero point 0.1 mole of HF will neutralize with the zero point 0.1 mole of NaOH, 0.1 mole of the weak acid remain, and then will produce zero point 0.1 mole of the salt. In any solution, when we have an amount of the weak acid with its salt or weak base with salt, we can say that it's a buffer solution. Let us talk about the other combination when they are equal. Do they form a buffer solution? No. Why? Because HF completely consumed NaOH. There will not be any amount of the weak acid here. Only the salt remains. So it's not a buffer solution, guys. And then if the amount of the strong is higher, the strong remain with the salt, but the weak, there is no, it's completely consumed. For buffer to be formed, the weak should stay with its salt. So it's not a buffer solution as well. Let us solve a type of question here, guys. Uh, This will be a question in this type of buffer. Which mixture form buffer when mixed? When it's between strong acid and weak acid with their strong base and strong acids, we have to know that the weak acid and the weak base concentrations should be always higher than the strong acid and a strong base concentration. And be careful that, guys, always the weak and the strong, they should be opposite to each other. A weak acid with a strong base, a weak base with a strong acid. They should not be the same, weak acid with a strong acid or weak base with a strong base. Guys, zero point 0.2 mole of NaOH or zero point 0.1 mole of HF here, it does not form buffer because the amount of the strong is higher than the weak. The amount of the strong and the weak, they are equal. It won't form buffer. The amount of the weak is higher than the strong, so it forms buffer. Here the amount of the weak is less than the strong, it does not form buffer. So C is the correct answer because the amount of the weak is higher than the strong. Guys, that's all about the buffer solution, the types of buffer solution. We have solved questions in order to know how to be prepared. Thank you for the attention and wish you all the best, guys.